Welcome back. As usual, I have to set my clock to make sure, stopwatch rather, to make sure I don't cross 20 minutes maybe, but it depends on the question. So this is a set of mixed examples on integration, set 5. No, my numbering was so horrible, I've been jumping around. So today we went through the whole videos and I realized I hadn't done set 5. I had got them on my paper, but I had not done it. So I'll put the questions down and we'll solve them one by one. Oh, by the way, my name is Susale Mohana. I have taught A-level maths for a long time and I'm recording these lessons to help you revise or go over what you learned in school and prepare for an exam. Right, let's take question number 1. Integral sec x tan power 5x dx. If I differentiate tan, I get sec square. I don't have a sec square and I can't do sec squared and do 1 over sec x outside. That doesn't work. Whereas, when I differentiate sec x, I get sec x tan x. But I only have one sec x, I don't have another sec x. Let us see. So can I write this as tan power 4x times sec x tan x dx. Oh, what's the big deal? I still have tan power 4. I can't integrate tan power 4 because when you differentiate tan, you get sec squared. But you put a sec x tan x. However, can you write this as tan squared x the whole squared times sec x tan x dx? I purposely put that in bracket because I'm going to use inspection. So can I write this as sec squared x minus 1 the whole squared times sec x tan x dx. So if I were to call u as sec x, this will become u squared minus 1 whole squared du. I'll leave it to you to figure out how to arrive at it, find du by dx, make dx the subject, substitute, simplify. So it's integral. I can't integrate directly because when you differentiate u squared minus 1, you get 2u and I don't have a u. So what I'm doing is, I'll write this as u power 4 minus 2u squared plus 1 du. So that's u power 5 over 5 minus 2u cube over 3 plus u plus c. I can remove u over 15 as a common factor. I get 3u power 4 minus 10u squared plus 15. So that is sec x over 15 times 3 sec power 4x minus 10 sec squared x plus 15 plus c. So even though it looks as though it's an impossible question, a bit of thinking and a bit of understanding the method of substitution, you should be, in other words, the moment I saw sec x tan x, I knew I'm going to get a tan power 4, which can be written as tan squared, can be written in terms of sec squared. And differentiate, when you differentiate sec, you get sec tan. That was my logic. Good. Now let's look at the next question. As you can see, I've got now, question 2 is integral 1 over u squared minus 6u plus 17 du. Straight away I know it's a rational expression. What's the rule for rational expression? Is it a proper fraction? Using colloquial language. Meaning the highest power in the numerator must be smaller than the highest power in the denominator, which it works. Good. Next, differentiate the denominator. I get 2u minus 6. Do I have a u minus 3 or a 2u minus 6 in the numerator? No. So, I can't use f dash of x over f of x. Next, can you factorize u squared minus 6u plus 17? You can't because 17 is a prime. So I can't factorize. So it's a proper fraction. It's not f dash of x or f of x. I can't factorize. The only choice is complete squares and use the standard formula. So what complete squares would I do here? It's 1 over u squared minus 6u plus 9 plus 8 du. Because I could see it's u minus 3 whole squared. So it's integral 1 over root 8 the whole squared plus u minus 3 the whole squared du. Remember the formula. Integral 1 over a squared plus x squared is 1 over a tan inverse x over a. This resembles that. In place of a, I have root 8. Perfect. In place of x, I have u minus 3. When you differentiate u minus 3, you get 1. So I can apply the formula directly because the derivative is a constant. So it is 1 over root 8 arc tan u minus 3 over root 8, or 2 root 2, how would I put it, 1 over 2 root 2. So it's root 2 over 4 arc tan, is that correct? 1 over root 8 is 1 over 2 root 2, multiply by root 2, divide by root 2, I get root 2 over 4. So root 2 over 4 arc tan u minus 3 root 2 over 4 plus c. In this question, I've just gone over the various methods of integrating a rational expression. Well, the next one is quite interesting. I hope I'll be able to do that. You've been given a substitution. X squared equals 1 over u. Look, you can differentiate with respect to x. So 2x equal to minus du by dx. So dx equal to minus du over 2x. Okay? Doesn't seem to. And when x equal to 1, 1 minus u equal to 1, so u is 0. When x equal to 2, 1 minus u equal to 4, u equal to minus 3. Okay, I've changed the limits. Let me simplify that. 1 over, first let me do x squared root 5x squared minus 1 will be 1 minus u root 5 times 1 minus u minus 1. Oh, sorry, what am I saying? What am I doing? I am sorry. X squared is 1 over u. So, 1 over x squared root 5x squared minus 1 is 1 over u root 5 over u minus 1, which will be 1 over u root of 5 minus u over u. So, which will become u squared over root 5 minus u. So, can I write this minus du over 2 root u? Oh, after doing all this, let me write the question first. So, it's integral 1 to 2 1 over x squared root 5x squared minus 1 dx equals integral 1 is 0, 2 is minus 3, this one is u squared over root of 5 minus u times dx is minus du over 2 root u. I wonder how to integrate this. Oh, let us see. So it becomes, so let me write all that here. Let me confirm I am right. X squared is, what am I doing? I think that's new. I knew I'd gone wrong somewhere. Sorry, like an idiot, I used the wrong substitution. Idiot. I had 1 minus u somewhere in my mind. Where did I have it? I don't know. Idiot. X squared is 1 over u. So u is x power minus 2. Du by dx is minus 2x power minus 3. So dx equal to du, or let me write this as minus 2 over x cube. So dx is equal to minus x cube over 2 du. I am an idiot. Sorry, not you, it's my fault. I don't know where I got that 1 minus u in my mind. I can't remember. Doesn't matter. Now, limits. When x is equal to 1, u equal to 1. When x is equal to 2, u is equal to quarter. So those are the limits. Whew! Idiot. So it's 1 over x squared root 5x squared minus 1 will be 1 over u root 5 over u minus 1, which is 1 over u root 5 minus u over root u. So it is u root u over root of 5 minus u. So I have integral 1 to 2. See, one stupid error and I was coming across an impossible integral. I knew I'd gone wrong somewhere. Idiot. Where I got that 1 minus u from, I still can't figure out. It is 1 over x squared root 5x squared minus 1 dx is equal to integral. The new limits are 1 and a quarter. U root u over root of 5 minus u times minus, what is x cube? X is equal to 1 over u, x squared. So x is 1 over root u. So x cube is 1 over u root u. So times minus 2 over, what am I talking? Times dx. So what is dx equal to? Minus x cube is 1 over u root u to du. U root u cancels. So the whole question comes down to, I was so stupid. So it is minus half integral 1 to quarter root of 5 minus 1 over root 5 minus u du. I can interchange the limits and integrate. So I get rid of the minus sign. So I have half integral quarter to 1 5 minus u power minus half du. That was impossible to integrate, and my first method was impossible to integrate. Idiot. But then, when I realized my mistake, I did correct myself. So if you persevere, what you do is find dx, change the limits, whatever is the expression, work out outside, then put everything back into the question. When you simplify, generally it's a straightforward integral, which we have here. When you differentiate 5 minus u, I get minus 1, which is a constant. So I can integrate directly. So it's half times 5 minus u power half over half between quarter and 1. Okay, let's integrate that. Let's simplify that. This goes with that. So it is 4 power half minus 5 minus quarter power half. 4 power half is 2 minus 4 5s are 20. 20 minus 1 is 19. Root 19 over 2. Yeah. x squared is 1 over u. So x is 2, 4 is 1 over u is 1 over 4. Yeah, it's okay. So it is 4 minus root 19 over 2 is the answer. That was a question. I like that question because I wanted to show you how a substitution can lead to a very simple integration. Otherwise, as such, you can't integrate that unless you use x equal to sec squared theta, 1/5 sec squared theta or something like sec theta or something like that. So this would be an easier way of doing it. The next question is actually, I don't want to go into the theory behind it, is to do with, look, integral, let's say, sin x dx between 0, integral, let's take it as x squared dx between 0 and 1 is x cube over 3 between 0 and 1, which is 1/3. Suppose integral 0 to 1 y squared dy, it still is 1/3. In other words, integral 0 to 1 x squared dx is the same as integral 0 to 1 y squared dy. That means, as long as the function is the same and the limits are the same, inside, whether you have an x or a y or a donkey or a z, the independent variable, it does not make a difference. Keep that in mind because that is very necessary to solve the next question. This question I remember way back in 1981, the Kenyan A-level, they had given that question. Prove that. So it's integral 0 to a f of x dx, and you're asked to use y equal to x minus a. So what's dy by dx? Is 1. Oh, sorry, a minus x. So what's dy by dx? Minus 1. So dx equals minus dy. Yeah. Let's look at f of a minus x dx. Okay. So now it becomes, and when x is 0, y is a. When x is a, y is 0. So it's integral a to 0 f of y dy with a minus sign. I can absorb the minus sign by interchanging the limits. So integral 0 to a f of y dy is the same as integral 0 to a f of x dx. Use y equal to a minus x to show that integral 0 to a f of x dx is equal to 0 to f of a minus x dx. So I started with f of a minus x, put y as a minus x, and then I have proved, remember, the limits are the same, both are the function f, so whether you have a y or an x, it does not make a difference because you're going to substitute the limits. And he says, use this result. So let me write this result on the side because it's a lovely question. I love this. 0 to a f of x dx equals integral 0 to a f of a minus x dx. Yeah. It's symmetry about x equal to a over 2 or something like that. So anyway, now I have integral 0 to pi x sin x over 1 plus cos squared x. Let me call this as I. Look, 0 to a, 0 to a. F of x, f of that should be equal to integral 0 to a, you raise pi. In place of x, write a minus x. That means in place of x, can I say pi minus x? Sine pi minus x over 1 plus cos squared pi minus x dx. Using the result in part A. So I'm using that result. So can I write this as integral 0 to pi minus x. 180 minus x is in the second quadrant. Sine remains a sine because 180 is an even multiple of 90. So, and second quadrant, ASTC, remember that? Sine is positive, so it is sine x over 1 plus cos of 90, 180 minus theta is minus cos theta, but when you square it, it remains as cos squared. Can I split this into two integrals? It is 0 to pi sine x over 1 plus cos squared x dx minus 0 to pi x sine x over 1 plus cos squared x dx. Now see the beauty. This is I. And I have I on the left, so I can take that to the left. So it becomes 2I equals integral 0 to pi. I can remove a pi outside, sine x over 1 plus cos squared x dx. Yeah. So far so good. Do you understand this? So f of x, this is f of x. F of a minus x, a is pi. So that's f of a minus x. Use cos of 180 minus theta, sine of 180 minus theta, simplify, and you got that answer. Now, when you differentiate a cos, you get a sine. So can I write this as I equal to pi over 2 integral minus sine x over, and I put a minus sign here, 0 to pi 1 plus cos x the whole squared dx. Yeah? Suppose I were to call u as cos x, du is equal to minus sin x dx. And when x is 0, u is 1. When x is pi, u is minus 1. So it is minus pi over 2 integral 1 to minus 1, 1 over 1 plus u squared du, which is minus pi over 2 tan inverse u between 1 and minus 1. So that's minus pi over 2 times tan inverse u is tan inverse minus 1 minus tan inverse 1. Tan inverse minus 1 is minus pi over 4 is minus pi over 4 minus pi over 4, which is minus pi over 2 times minus pi over 2, which is pi squared over 4. Otherwise, this question you will have to call x as u, sin x over 1 plus cos squared x as du by dx. You end up getting a integral of tan inverse cos x or something like that. God bless you. So the only way you do it is you recognize the symmetry and then use this result. That's how you show the answer. Hope you enjoyed these questions. This is 23 minutes. Not bad, yeah? I'll see you next time. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded and launched. Thank you very much.